Hi students, this is Miss Whitaker, and here is the lesson for today. This is one of the pages. The first thing I'm going to do is I'm going to kind of refresh and review some things that that might help you before we start. And I'm not going to go over the problems individually, but I think these vocabulary words will help you when we talk about this. I know when the questions in the beginning talks about the powers, and remember the power is, and you probably didn't even realize it was called a power, was when you see a big number with a tiny little number beside it. The 7 is called the base. Okay, it's the large number. And the little 3 here is called the exponent. And the exponent, oops, let me go up here, large number, that was 7. And then the exponent was the little number, and that was the 3. And what it is it's not 7 times 3. That would be like repeated addition, and that is not when we have powers involved. When powers are involved, we do something called repeated. Let me find a good color for this. We do repeated multiplication. So you might see in this case we would take the 7, because that's the number, that's a large number, that's the base. We start with that base, and the exponent tells us how many times we're writing that base. And again, we're doing repeated multiplication. So you might see where they do it like this. They might do it where they do decimals. They might do it where it would be parentheses. But all of these show we're doing repeated multiplication. So it is not 21. That's usually the biggest mistake the students make. So again, let's review. This is the whole thing is called the power, all of this together. The big number, the 7, is called the base. The little 3 is called the exponent. And what do we do with these numbers? We do repeated multiplication. So we take that base and we repeatedly multiply it with that exponent amount. So if I was going to evaluate this and actually solve it, I would do 7 times 7, and then I would get 49, and then I'd multiply it times my last 7. So 49 times 7 would give me 300, I believe, and 43. Hope I did that right, but I did it in my head, so hopefully, but it's definitely not 21. Okay, so let's take a look. I'm going to go to another page, and we're going to talk a little bit now about numeric expressions. Remember, a numeric expression is a problem with numbers. Oops, and it would look something like this: 7 plus 3, or it might be, 7 to the second power plus 3. Those are numeric expressions. And then we have something called algebraic expressions. And again, all expressions are problems. They're not with answers yet. And algebraic expressions has numbers and letters involved. So it might look something like this. Okay, so we have letters and numbers involved. Okay, now within algebraic expressions, we have something that we call a coefficient. Coefficient is always what is beside the variable. So the coefficient would be beside m or x or y or whatever it is. And it has to be touching it. It has to be multiplied by that variable. What the variable is being multiplied by. So if I'm looking up in this problem, the coefficient would be the 7 because it's right there next to the m. If I ask you for the coefficient of here, okay, I don't see a number next to m, but I do know if m is by itself, that means there is just one of them. So the coefficient could be 1 in that situation. So that is coefficient. The next word would be a variable. A variable is just any letter that you're using in your problem that can change. It varies, whatever you decide to plug in for that letter. So in this case, if I look up, I see that I have M in my problem, so M would be the variable. The last thing I'm going to work over here a little bit is we have the constant. That's probably new to a lot of kids, but they probably just didn't realize it was called this. The constant is your actual number that's by itself in the problem, which that would be, in this case, it would be plus 3. So a 3 is the constant in both of those problems. It's never going to change. It's going to be 3 unless you add it with another term or take it away, or you subtract it from another term. So, so it's usually just the number by itself. Then, I forgot about this, now that I just said this, we have terms. And terms are the things that are grouped together around your operations. So, in this case, we would have 3 terms, and I could fill them in those boxes. It might be 4 plus 3x minus 2y. So we have 3 terms because we have 3 groups of numbers or variables around our operations, which are plus, minus, multiplying, or dividing. So there's some vocabulary that we talked about all week long, and those might help with our homework tonight. So let's go back to what we had for homework. Okay, so at the top you should be able to answer the things that we just talked about. Oh, the only thing I did not discuss, which was evaluate. Evaluate means to solve, and we've talked a lot about that as well. And the ones below here, you have to solve them, but you have to remember to use Pemdas. Okay, and this is also in your notes in the back side of your prep work tonight. And you have to follow an order. They're called like rules that we have to follow when we're solving problems. The P stands for parentheses. The E stands for like your exponents. Multiplication, division, they are equal to each other. It's whatever comes first when you're going left to right. And addition and subtraction are also equal. And it's, again, how you come to it left to right. So, an example would be if I had this problem, I might do something like 7 plus 3 divided by 1 times 8. Okay, so I look at my problem and I say, okay, do I have any parentheses? Nope, so I'm done with this. Do I have any exponents? Nope, so I move on. Do I have any multiplication or division? Yes. So I look left to right, starting at my 7, left to right, and I move across. And I notice right here I have division, but I also have multiplication. You have to do the division first because it came first. So I might box these, and then I would solve it. 3 divided by 1 is 3, and now that cancels out because I've solved it, and then I rewrite my problem. I strongly suggest that you rewrite your problems every single time until you get to your final answer. It just keeps you organized. So now I've done the first, I did division, but I also notice I still have multiplication. So I'm still kind of like in this area right here. I've already did the division. Now I still have a multiplication. If I did not have multiplication, then I move on to this box. So I have multiplication. I'm going to box what I'm solving next. I can focus just on that, which is 3 times 8. So I solve that, and I get 24. Oops. And then I fill in. I've answered that. Now I plug in what was there before that I have not solved yet, and now I have 7 plus 24. So I have completed my multiplication and division, and all I have left now is addition and subtraction. So if I had subtraction in front and then multiplication or then addition, I would do the subtraction first if it came first. But now we're just left with are 7 plus 24, so that's all I have to solve, which that would equal 31. And so now I've just solved and got to my final answer. So now I can check off I did addition and or subtraction. So basically, I suggest you definitely follow in these steps. You start with step 1, then you go to step 2, then you go to step 3 until you get to your final answer. Okay, let's go to your next set of problems. Let's see. Down at the bottom, it says admission to a football game costs $1.75. Now, they could have asked you in this question, I think they did have this, but I took it out. They want you to figure out what expression would you use to solve this, depending on the situation. And we know that there is $1.75 per student. Per is a good word to signify that you're going to be multiplying. Okay, you're going to be multiplying by however many students you have. We do not know how many students, so it might look something like this. We might be doing it's $1.75, and we might say times X. Or what they do is they kind of squish them together. They'll say $1.75 X, and then you just plug in X. So for the first one I see it says 75 students. So now they're going to check also, do you know how to multiply with decimals? So we're going to see if you remember this. Remember, it may be different when you're multiplying than when you're adding a decimal. You do two different things, so make sure you're paying attention that we're multiplying. And then for the second one, you do the same exact thing. You do $1.75 times 185 students. Okay, again, you got to remember what to do with your decimal. Also, I will be looking to make sure that you are showing your work for these, so we're not just using a calculator. Go to the next page. Let me clear it. Okay, on this one, you want to look at, this one was kind of tricky for students, the top one here. They didn't know what they were supposed to put in this box. Okay, well, they want to know, what are you doing with X? And all of these numbers would be X. You can plug them in. Remember, variables can change. And whatever you do with this X, it has to equal what is across from it. Okay, so if I look at the first one, I see X, and the first X would be 3, so I might plug in 3. And what operation would I do, and what number would come behind it that would equal 6? Well, you could do a couple things. You could do 3 times 2, so that would mean you would do X times 2, and that might be what you put up in that top box, because that does give you 6. But there's another thing that also gives you 6. You could do 3 plus 3, and that also gives you 6. So you might put up in that box X plus 3. But whatever you pick, either one of these two, it has to work for all of the numbers. So just remember that. Evaluate. Again, that word evaluate means to solve. So if you look, this is your original problem. Okay? Now they want you to you cannot solve it the way it is right now. It's an expression still. So to solve it, you have to know what M is. So what you would need to do is you need to probably have some space, and you're going to plug in M. And they say that M is 4. So wherever I see M, I'm going to plug in 4. 4 still to the second power over 2 minus 3. And then you have to solve this problem. That's why it says evaluate, to get to an answer. Now some problems might even put M, they might put a couple M's in there. So always be ready for that. And if they did put 2 M's in there, and it was like a long problem, they could do something like this. M over 2 plus 3M. They could do something like that. Well, it doesn't matter if you have 2 M's, you would still plug in 4 every time you saw an M. Why did I say on the next part, remember tricky T? Tricky T meant that word than. If you see the word than, that means switch. Whatever's in the front goes in the back. Whatever's in the back goes in the front. We also have the word tricky F. That word F stands for from. Same thing for from. Whatever's in the front goes in the back. Whatever's in the back goes in the front. So hopefully those keywords will help you to know what to write down. an algebraic expression, again, is a problem with numbers and letters. So all of these should have numbers and letters. And I look and I see N for all of these. So that looks like that's going to be the variable or the letter that you use. Rewrite these using distributive property. Remember, if it's right up next beside the parentheses, that means you're multiplying. We always say the saying, side by side you multiply. So a lot of times people think that you just work out what's in the parentheses, get your answer, and then multiply by 6. But that is not using distributive property. Distributive property means you're going to distribute this 6 with everything inside. So you're going to do 6 times x, which would give you 6x. And then you're going to do 6 times 4, which would give you 24. And so this is what they're looking for, okay? And you can also use dividing also. So here I notice that they have distributive property where you multiply like we just did. Then you're also going to be distributing that 2 when you get done with everything on top. And I notice it's the 2's on the bottom. And remember, a fraction, and it will look like kind of like a big fraction, is just a division problem waiting to happen. So you'll be dividing that 2 once you do your distributive property right here, and then you put the -5, then you distribute 2 with everything that you have on top. You're dividing by 2. Last page. And here we talked a lot about these words. What's the number of terms? You should definitely know that. You should know the coefficients. You see it's plural. They can be more than one. The constants, again, it just says constant. So to me that looks like there's just going to be one. Factors is tricky. Factors are the factors are the things that you can pull out of your numbers. So what's a common factor that you can pull out for all of these numbers that can go into each of those numbers? You're going to find out what those numbers are. There could be 1, there could be 2, there could be more. Represent the algebraic expression using algebraic tiles is what we practiced today in class. Remember, if it's a number that says x to the second power, those are kind of represented with big boxes. If it's just x, it's more of like a long rectangular box. And if it's just like a number, like maybe 1, it's represented with a small box with that number inside. Again, you would put like x here, and inside here you put x to the second power. So if I had 2 x's, if it said 2x, then I would need 2 of these. If I had the number 3 in it, then I know I need to have 3 of these. So you can sketch them all here. We talked about this in class. It was on your homework. And then after you get done doing that, then we want to say, can we put any of our things together, any of our like terms? Because right now I see that we have 1, 2, 3, 4, 5 terms in this original problem. Can we combine anything that looks alike that we can get less terms? This next part, simplify the algebraic expression, again, by combining your like terms. Okay, same thing. It's kind of like what you did with B here. But now we don't have pictures. We're just now combining our like terms. So you guys see if you can make it smaller. I notice we have 1, 2, 3, 4, 5 terms. Can I get smaller than that by combining some things that look alike? Last part, simplify each algebraic expression using distributive property first and then combining your like terms. So you can do distributive property here, you can do it here, and then combine all your like terms. Same thing with B. Again, I hope this helps. And, again, I'll do a couple more things. I'll have to be quick because it's about to die. I know I want to talk a little bit about if I have 7. We already do it like this. If I did, 7 must be my favorite number today. 4 to the 3rd power. Remember, that's not 12. It's 4. It's repeated multiplication. 4 times 4 times 4. If I say 4y, that is repeated addition because I see multiplication here. So that would be y plus y plus y plus y. I have 4 y's. Okay? So I know that's kind of tricky. We've talked a lot about that in class. Don't forget about distributive property. If I have, there's that 7 again. Distributive property, you're distributing the 7 with everything inside. And you're multiplying because he's side by side. So 7 times 2 is 14. And then you're doing 7 times y, which is 7y. And so this is your new problem once you did distributive property. I hope this helps. You have a good night, and I look forward to seeing everybody done with their homework tomorrow. Thank you.